Today we will discuss few more problem on langrage equation. What is langrage equation? A equation of the form PP plus QQ is equal to R, which is a first order first degree linear equation, linear partial differential equation. Now, because it is a langrage equation, we have the auxiliary equation in this form: dx by x square is equal to dy by y square is equal to dz by x plus y z. From this auxiliary equation, we can form this one: dx minus dy divided by x minus y, dx minus dy divided by x square minus y square. That can be written as x plus y into x minus y is equal to dz by z into x plus y. Now x plus y is cancelled out and it becomes dx minus dy divided by x minus y is equal to dz by z, which on integration gives us ln x minus y is equal to ln z plus ln c. Take ln z to the left hand side and it becomes ln x minus y minus ln z, which is ln x minus y by z is equal to ln c, which taking exponential both sides, we get x minus y by z is equal to c1. So this is the first relation we obtained from the auxiliary equation. Again, using the multiplier 1 by x in the first two ratio, dx by x plus dy by y is equal to dz by dz. dx by x plus dy by y divided by x plus y is equal to dz by z into x plus y. So x plus y is cancelled out and it becomes dx by x plus dy by y is equal to dz by z. Now integrating, we obtain ln x plus ln y is equal to ln z plus ln c. Take ln z to the left hand side and it becomes ln xy by z is equal to ln c, and on taking exponential both sides, we obtain xy by z is equal to c2. So the general solution is, this is the first relation we have obtained, x minus y by z, and this is the second relation, xy by z. So f of x minus y by z and xy by z is equal to 0 is the general solution, where f is an arbitrary function. Consider another problem. Y square p minus xyq is equal to x into z minus 2y. This is also in Lagrange form, so we construct the auxiliary equation: dx by y square is equal to dy by minus xy is equal to dz by x into z minus 2y. So from first two ratio, we can write dx by y square is equal to dy by minus xy. Y is cancelled out from the denominator and it becomes dx by y is equal to minus dy by x, or it can be written as x dx plus y dy is equal to 0, which on integration gives us x square plus y square by 2 is equal to c1. 2 is multiplied and it becomes x square plus y square is equal to c1. This is the first relation we obtained from the auxiliary equation. Again, dy minus dz divided by minus xy minus xz plus 2xy, dy minus dz, dy minus dz minus xy minus xz plus 2xy plus 2xy minus xy, it becomes xy. So it is xy minus xz. So if we take x common, it becomes x into y minus z. So this can be written as dy minus dz divided by x into y minus z is equal to dy minus xy. X is cancelled out and it is dy minus dz divided by y minus z is equal to minus dy by y. Now on integration, this gives us ln y minus z and this is ln y. So we have ln y minus z minus ln y plus ln c. The arbitrary constant is taken in logarithmic form for simplicity of calculation. Now it is ln y into y minus z if we take this expression to the left side. So y minus zy is equal to c2. Then we take the exponential both sides and obtain this. So this is the second relation. This is the first relation. So the general solution is f of uv is equal to 0 or f of x square plus y square and y minus zy is equal to 0, where f is a arbitrary function. So this is the general solution of the given differential equation. Consider another problem. Question 3. X into y minus zp plus y into z minus xq is equal to z into x minus y. This is langrage equation. So the subsidiary equation are dx by x into y minus z plus dy is equal to dy by y into z minus x is equal to dz by z into x minus y. So from the three ratio, if we add the numerator, we will add the denominator also. So dx plus dy plus dz divided by x into y minus z plus y into z minus x plus z into x minus y. The denominator become 0. So what we get is dx plus dy plus dz is equal to 0. On integration, we have x plus y plus z is equal to c1. Again, in the auxiliary equation, if we multiply 1 by x, 1 by y, 1 by z, using the multiplier 1 by x, 1 by y, 1 by z, we have dx by x plus dy by y plus dz by z is also 0, because y minus z plus z minus x plus x minus y is 0. So the denominator again becomes 0. So we take the numerator to be 0. Now dx by x plus dy by y plus dz by z is equal to 0. On integration, we get ln x plus ln y plus ln z is equal to ln c. This is the arbitrary constant. So it is ln x y z is equal to ln c. On taking exponential both sides, we get x y z is equal to c2. So the general solution is x y z is equal to pi, x plus y plus z is equal to pi of x y z. In this way also we can write the general solution. U is equal to pi of v, where u is the first solution, v is the second solution. X plus y plus z, x y z are the two solutions we have obtained from the auxiliary equation. So the general solution can be written in this way, or you can write it as f of x plus y plus z and x y z is equal to 0. Both way it is correct. Consider another problem. Y minus zx into p plus x plus yz into q is equal to x square plus y square. This is a langrage equation. P plus q is equal to r. So the auxiliary equation are dx by y minus zx is equal to dy by x plus yz is equal to dz by x square plus y square. Now using the multiplier x and y in first two ratio, x dx minus y dy, x dx minus y dy. X is multiplied here, y is multiplied here. So xy minus zx square plus xy plus zy square. So xy is cancelled and it can be written as z into minus z into x square plus y square. So x dx minus y dy, the denominator becomes minus z into x square plus y square is equal to dz by x square plus y square. Okay, so x square plus y square is cancelled out. If we multiply z with dz, okay, then we have x dx minus y dy minus z dz is equal to 0 minus z. So it is plus, it becomes plus z when it if we take it into the left hand side. So what we get after simplification is x dx minus y dy plus z dz is equal to 0, which on integration gives us x square minus y square plus z square is equal to c2. Okay. So this is the first relation. Again, y dx plus x dy, if we use the multiplier y in first ratio and x in second ratio. Then it becomes x square plus y square minus xyz plus xyz. Y dx plus x dy. Y dx, y is multiplied here and x is multiplied here. Y dx plus x dy. Then it is y square minus xyz. It is x square plus xyz. So y dx plus x dy is this much. Xyz is cancelled out and dz by x square plus y square. So x square plus y square is again cancelled out from both the ratio from the denominator, and it becomes y dx plus x dy is equal to dz. Y dx plus x dy is d of xy is equal to dz, which on integration gives us xy is equal to z plus c2, or xy minus z is equal to c2. So we get two relation. Hence the general solution is x square minus y square plus z square is equal to phi of xy minus z, where phi is an arbitrary function. In this way we solve the langrage equation, which is a partial differential equation of first order linear.